Alright, today I'll be showing you how to use the Dymola interface for UNCC FSAE 16. As you can see, we opened up Dymola from the start menu. First thing, we're gonna change our directory, but let's make sure we have the libraries we need. So we have the VDL Motorsports library, you can see it right there, and the Vehicle Dynamics library is also here, as you can see. So we're going to go ahead now and change our directory under the File tab. Below Search is Change Directory. So we're going to do that, and we're going to go to, I'll do the whole path here, we're going to go to n:/uncc.edu, user 8, motorsports, formula SAE, 2016 FSAE, Dymola. Select that folder, where you can see a couple subfolders here. We don't really care about those. This will allow us to access some images and files that I've saved in that folder. Now you're going to go File Open FSAE Model 2016. You can see it's loading, opening everything. Make sure you have access to the Motorsports drive or you won't be able to do any of this. So assuming you're on the FSAE team and have access, you should be able to do everything in the Dymola suite. So you can see we populated all of our goodies here. We've opened up the main folder of user interface Dymola tools. So what we're going to do today is just show you how to run these. So I must have double clicked there on accident. So front kinematics with tire squish, we'll open that one up. It's just a basic front kinematic model. Looking around, we can go inside components. We can browse our geometry record. You can change the geometry record. Here we only have this one example, so we're not going to change that. So you can go in, you see we have our twin damper set up, there's our right linkage. Can't change the class from here, so what you can do is you can double click, open in the new tab, the front suspension model, and go in there and you can make your changes from there. So that's how you have the freedom to make a part change. You'll just do it like that. So let's switch over to the simulation tab. As you saw, we clicked. We're going to say simulation setup. Stop time's 10 seconds, that's fine. LSODR is my preferred algorithm. It's more robust than the DISSOL solver, in my opinion. So now we'll wait. It should be 10-15 seconds. Maybe a little longer since we're on Mosaic Anywhere. As you can see, this is a front kinematic model, so we'll just be watching some motion and make some comments on it, and that's really all we're going to be doing with this test. So you can see the variable browser is populated now. That means simulation started. You can see that there was some sensors that I added in: an anti-dive, heave sensor, toe sensor, caster kingpin inclination sensors. You can add these sensors in as you please. Make sure that you reference them to the right parts or you won't get anything that means anything to you. So you can see integration finished, 10 seconds, says CPU time was 0.406 seconds. Of course, it took longer than that for it to translate the system. So it's solving a bunch of differential equations, many orders, hundreds of thousands of orders of magnitude of equations. So we're going to make this guy big, take a look at it. You can see top view here. I'm going to rotate it around, holding down Control and left click to rotate and spin. Conversely, you can also go to the animation 3D view control. I'll do it in a second here because I'm probably going to get fed up with it. No, it's good enough. We can see what we wanted to see. You can see that it didn't really have much travel. I'd like to add some steering input, so I'm just going to go to the steer controller, change the start time on that controller to 1 second. I'm going to go in here, set the parameters on the car. Okay, everything looks good. Nothing to change. I'll just go in there and double check that everything looks like I thought it did. And then I'm going to go into my rig controller and change my wheel travels. So right now I think they're set to 1 inch of travel. We'll go and do I don't know. We'll do 0.1 meters. Pretty much we're working in mostly metric system in Dymola. So let's do 0.1 meters. That'll give us, 4 times the travel, which should let us actually see some motion. We weren't seeing a lot of motion with an inch. So we'll do that. We'll go ahead and re-simulate this model, so a little more weighting again. Alright, that simulation's done. I try to rotate it. Okay, so you can see it can be frustrating trying to manually rotate this. So like I mentioned before, we can go up here to animation and hit 3D view control. Bring this guy over, and then you can just click with the mouse buttons to get a better view and get what you want. I kind of want this YZ plane, so I'm gonna get this YZ plane looking good, and I'm gonna say I'm happy with that. So close that out, go ahead and run. Look at that, we got a steer source on it now. So the steer source is a little faster than I'd probably do if I was trying to see anything with gains, but still, nonetheless, because you get some compliance and induced kinematic secondary oscillation motion by steering so fast. So I'd probably slow that down if I wanted to do some quasi-static analyses of any sort. So we also have our rear. Just pop open a rear model, show you that that one runs too. I could cut out these run times, but I want you to get a feel for how long it takes between the simulations, so you know it's working. You don't get discouraged. It does take a little while to simulate, especially on the Mosaic Anywhere or the older Mosaic PCs, though, like in Duke 242. Those ones can take quite a little while. So there you go. There's our rear. Push rod, actuated. Alright, boom, she's running. So that looks good, so we'll go back into the modeling environment. What I wanted to show you now was our full car. So we're going to double click closed loop test underscore FSAE. You can see we have our full car model with a driver who has an accelerator gear, tracking, and perception robots. So this driver is closed loop. So we're going to go ahead and call a track. It should be the one under FSAE Track Builder. You'll see that I'm going to purposefully make a mistake here just so I can show you that sometimes you don't notice something and you think you got it working and it won't work. So I'll show you what I mean. So we're going to say show preview, continue. I'll just hit enter. So we're going to go ahead. Track generates. We're on Anywhere, so it's going to be a little choppy here with the graphics, the animations. But you'll get the point. So we have the track animated, and we're going to go ahead and take a look at the track and say, okay, so this is what my simulation should be. So zoom out with the middle mouse button. See our dinky little track, rotate it with the control key. So there you go. So with that being said, let's go back out. Okay, looks good. Simulation, set it up. I'm going to run it for 45 seconds since this is about how long it takes for the car to run a lap here. We could program something into time lapse.